Hello friends, today question. Two blocks of masses m1 and m2 are connected with a light spring of force constant k and the whole system is kept on a frictionless horizontal surface. The masses are applied force F1 and F2 as shown in figure. At any time the blocks have same acceleration a0 about in opposite direction. So we are going to find out these three things: the value of a0, the value of the spring forces, and the third is if F2 is removed at this moment, then just after this the acceleration of m2 is. So these are two blocks m1 and m2. Forces F1 and F2 are applied in the opposite direction and they have the acceleration accordingly in the opposite direction with a0. As the spring is being compressed, let us say there is a restoring force kx in this direction and kx in this direction. Now let's write the equation of forces for block m1. You can say for mass m1 f1 minus kx is equal to m1 a0. Let us call this equation number 1. And similarly for mass m2, f2 minus kx is equal to m2 a0. This is equation number 2. Now if you subtract equation 1 and 2, equation 1 and 2, we get f1 minus f2 is equal to m1 minus m2. Let us take a0 as common. So from here you can write that our a0 will be equal to f1 minus f2 divided by m1 minus m2. So this is the acceleration. The acceleration of m1 and m2. So this is the first part. In the second part, we are supposed to find out the value of spring force. So we know value of a0. Let's use equation 2. From equation 2, substituting value of a0 in equation 2, we get f2 minus kx is equal to m2 multiplied by f1 f2 m1 minus m2. And here we can write this as f2 minus m2 f1 minus f2 divided by m1 minus m2 is equal to kx. Taking LCM, we get this as f2 m1 minus f2 m2 minus m2 f1 plus m2 f2 is equal to kx. And here these two terms cancels out, so you can write this as f2 m1. So you can say the force constant, the spring force will be equal to kx, and that will be equal to m1 minus m2. Okay, this is the denominator. So this will be coming as F2 m1 minus m2 f1 divided by m1 minus m2. So this completes the second part. Now the third part, it says if F2 is removed. Now spring has the property that it doesn't change its initial condition instantaneously. Okay, so we can write, it is said that if F2 is removed, okay, you can say the spring do not change from its initial conditions instantaneously. Therefore, even when F2 is removed, the force is going to remain. So this is our M2, and we have a spring force acting in this direction, that is Kx, and let us suppose the acceleration is A2, and here the F2 is applied previously, now it is equal to 0. So you can say for F2 is equal to 0, we can write the equation as Kx will be equal to M2 multiplied by A2, and let us use equation 2 and substitute value of Kx in equation 2. We can say from equation 2, equation 2 was our F2 minus Kx is equal to M2 A0. Here we substitute value of Kx, which we get this as F2 minus M2 A2 is equal to M2 A0. So we can say that our A2 is equal to F2 minus M2 A0 divided by M2, or which can further written as A2 is equal to F2 M2 minus A0. This is the acceleration when force F2 is 0. Acceleration when force F2 is removed, that is F2 is equal to 0. So this completes the question. Thank you.